grade 11s. So in the last video, I showed you guys how to plot a linear function and how to plot a quadratic function. So in this video, we have question 6, which is a question paper problem. It consists of 8 questions. So I'll be solving all these questions and showing you different tricks on how to solve them. These are like exam papers. So if you watch these videos and understand what's really happening, it's guaranteed that you're gonna pass. So in this case, we have, if you can check here, we have a linear function. Which one is a linear function? This one. And we also have a quadratic function. So this whole thing is a combination of two functions, which is a linear function and a quadratic function. So if you don't know what is a linear function, I advise you to go back to my previous videos and watch them so that you can understand. So let's start. In this case, we have the first question, which tells us to determine the x-intercept of f. So when the questions ask you about x-intercept, you already know that your y is equals to 0. Why am I saying that? So check this. So in this case, we are given the expression f of x is equals to negative x squared minus x plus 6. So we all know that f of x means y. So if you don't know, now you know. So y is equals to, okay, sorry for that. So y is equals to negative x squared minus x plus 6. So in this case, like I told you, when you see x-intercept, just know that you're going to substitute 0 into 1. When you see y-intercept, just know that you're going to substitute 0 into x. So in this case, which one are we going to use? We're going to use y is equals to 0. Why? Because they want x-intercept. So let's start. So in this case, we're going to substitute 0 into the y, right? Negative x squared minus x plus 6. So in this case, we have to solve for our x-intercept. As you can see, this function gives you a what? A quadratic function, right? Meaning that you have to factorize solving for x, right? So in this case, before solving for x, check something. You see the coefficient of the x squared is negative. So when you're given something like this, sometimes it can make it hard for you to solve a question. So an easier way to get through this is to make sure that you make your the coefficient of your x squared to be positive always. So how do we do that? So in this case, we're gonna say let's say is negative x squared, negative x plus 6 is equals to 0. So to change this, we have to divide everything by negative 1. That's a grade 9, grade 8 maths. So let's do it. So it's gonna be over negative 1 over negative 1. Okay, this is 6 over negative 1 over negative 1. So we're gonna get, okay, sorry, x squared plus x negative 6 is equals to 0. So in this case, we have our new form of a quadratic function. This is our new quadratic function. But if you can check, there is no difference, but we only changed the signs, right? So let's move on. Okay, let me just do this, right, to create space. So let's move on. So in this case, we have to factorize this thing. So there are many ways that you can factorize. You can use a quadratic formula, or you can use trial and error. So in this case, this is a very easy equation. This is a very easy function. So what we can do, we can use what? The trial and error. So in this case, we're gonna say, okay, 6. So it's 6 times 1, right? This is 6 times 1. Then, okay, to get 6, we can say 3 times 2, right? So in this case, 3 minus 2, it gives us what? 1, which is this 1 here. So in this case, we're going to have x plus 3, x negative 2. So if you don't really understand what is this, if you don't really understand factorization, I'm going to do separate video regarding factorization. But if you you understand based on your previous subjects and previous grades and everything, that's great. So in this case, we're going to have x is equals to negative 3, or okay, let me just show you the whole step. So in this case, we're going to say x plus 3 is equals to 0, or x negative 2 is equals to 0. So x is equals to negative 3 or x is equals to 2, right? So we have our x-intercepts. So if you have these two x-intercepts, you get your full marks. But in this case, you have to identify on this function, on this graph, where is your x-intercept and where's where's your x-intercept, like where's your -3 and where's your -2. So let's check. I'm gonna change the color. Let's change to blue, right? So in this case, if we can check in this side of the Cartesian plane, we have -x, right? In this side of the Cartesian plane, we have positive x. And you go back here. So in this case, for the first x, you got -3. It's telling us that our first x-intercept is gonna be on the side where x is negative. So the question is, which side is that? So which point is that? So the point is gonna be here, B. So our B is gonna be a 0 and sorry about that. It's gonna be -3 and 0. Why? This is our x-intercept. I showed you how to get our x-intercept, and in this case, now we are left with x is equals to 2, meaning that fundamentally our x is equals to 2 is gonna be this side. So this is a trick, guys. You know, when you're given an exam, when you are sitting in front of a question paper, just do this for yourself. Just save yourself and collect your marks. If you just identify your x-intercept, just know always you're gonna use your x-intercept. So just take your graph, you know, just take your diagram, your graph, your function, and just like label those things that you can do. So when you're given a function like this, a quadratic function, you can get the turning point and you can also get your x-intercepts. So just do all those things before you can start answering your questions, and then from there it's gonna be easy for you to like answer your questions step by step. So let's move on to the next one, which is 6.2. Let me just erase this. Okay, let me just erase this. Okay, so now we are dealing with okay, let me just change to black. So now we are dealing with 6.2. So our 6.2 says, write down the equation of the axis of symmetry of F. Right. So right now I'm assuming that every student that have watched my previous video on quadratic functions understand how to answer this question. Remember that I introduced this equation to you. X is equals to -b 2a. And again, I taught you that this equation helps you to find the x-axis of the turning point, which is the vertical line which is the axis of symmetry. So this equation is the equation that you use to get like the x-axis of the turning point slash the axis of symmetry of a quadratic function, right? So in this case, remember that you are given f of x is equals to, this thing is given, guys. I didn't come up with it. So it's going to be -x squared negative, okay, plus 6. So in this case, every learner who have watched my previous video again knows that our a is gonna be -1, b is gonna be -1, and c is gonna be 6, right? So in this case, we are looking for axis of symmetry. So we're gonna say x, and then we simply substitute everything into the equation. So in this case, our b is -1, and then our a is -1. So we're gonna have x is equals to -1 over 2. So this is your axis of symmetry, and then you get your full 2 marks. So the first 4 marks plus the second 2 marks, you already have 6 marks. So let's move on. Let's get all the marks. So let me just do this. Let me just erase everything again, sorry. Then we move to 6.3. So 6.3. So in this case, they say determine the range of F. So I know I haven't done a video on like showing you what is a range and everything, right? So in this case, I'm just gonna teach you how to determine and range and everything. So let's say you're given a function like this, right? You're given a function. Let's say it's a linear function. And they ask you what is the range. So if you can check, this function goes from negative infinity to positive infinity. So a range entirely focuses on the the vertical part, the vertical part of your function. If your function travels from here to here, let's say from 1 to 2, that's your range because it's a vertical part. You can't say your range is from here to here. No, your range always has to be like vertically, right? So in this case, if you can check this function, if you can check this linear function, its vertical part, like remember, if a function has this thing, it means it is continuous, meaning it moves to infinity. So in this case, this function is from negative infinity to positive infinity, meaning its range is gonna be negative infinity to positive infinity. And guys, I'm gonna teach you something again. You see, there are different kind of these brackets. So we have this kind and we have this kind. This kind means that your function touches that's exact position, but this kind means it doesn't touch. It reaches but it doesn't touch. I will show you just now. So the reason why when you state your range, when you like write your range with this function, you use this brackets, it means that your function is reaching towards infinity but it doesn't touch infinity. Guys, nobody can reach infinity. Nothing can reach infinity. Infinity is infinity, right? So in this case, let's answer the question so that you can see what I'm talking about. Right, so I'm going to answer the question on the actual function, actual diagram. Okay, cool. So remember we got our axis of symmetry, right? It's somewhere here. Let me just use a different color. So our axis of symmetry is somewhere here. Oh my god, I just changed to red. Okay, it's somewhere here. I hope it's visible. Yeah. And then here we have -1/2, like we said, right? So our axis of symmetry is right there. Let me just erase these for now. Erase this for now. So this is our axis of symmetry, right? Meaning here, okay, this here it's our turning point. Okay, meaning that's our turning point. So in this case, we have to get in this case, remember that we have our we only calculated the x coordinate. We only calculated the x coordinate of the turning point. We didn't calculate the whole thing. We only calculated the x coordinate. Okay, let me just do this. Which it gave us 1/2. But we didn't get the y coordinate. And in this case, remember I said the range focuses on the vertical position, like the vertical part of the function, meaning that it only focuses on the y coordinates, right? So in this case, our function starts from here, it ends from here, right? It starts from, actually it doesn't start from here, it comes from infinity, right? And then it ends here in this position, right? So vertically it comes from infinity and it ends here in this position, which is the turning point, right? So in this case, we do have the x coordinate of the turning point, but we don't have the actual y coordinate, which is the very same coordinate that we need to determine the range. So in this case, our range comes from the negative infinity. It doesn't touch, remember, but it comes from our negative infinity, and then it reaches this point here, it touches this point here, which is what we need, which is the y coordinate of our turning point, right? So in this case, we have our x coordinate of the x coordinate of our turning point. The question is, how are we gonna get our y coordinate? Simple. If you have watched my previous video, you will know by now that if we can just substitute into the original equation, into the original equation of the function, we can have something like, okay, let's see. We're gonna have something like this. Okay, negative 1 over 2 squared negative plus 6. Then okay, sorry, here you're gonna put that half. Where you see x, you substitute negative half. Where you see x, you substitute negative half. That's how you get the y coordinate. So in this case, you're just gonna put that into a calculator. Let's put that into a calculator. Negative 1 over 2 squared negative 1 over 2. Okay, plus, okay, what did I, oh, this is 6. Yeah, plus 6. Plus 6. Okay, cool. So in this case, we're gonna get 25 over 4, right? So 25 over 4